middle is going to be, I'm just going to abbreviate it, MED for your median. That's the one that did change a little bit, but it didn't go as far as the mean because it is resistant. So it shifted a little bit slightly, but not all that much. So now they want to know which one is the median. Well, for us, it's going to be B, because from the peak, it shifted a little bit, but not that much. So we're going to say B for that one. Check our answer, and that's it. Okay. And then 17 is going to be the same thing, only now they ask you which one is the mean. So the mean, since it's skewed to the right, it's going to be pulled over this way. So you'll select C for that one. If you do it wrong, and so these are all mixed up, so if you go, it's the last one and go down to A, check your answer, they'll tell you it's not right, and then you've got this final check. So if that's the case, just go back and make sure you have the right one. It's C, so you'll select C in that case. And then there's your final check. So 16 and 17 are similar. Questions on that homework 3.1? Okay, that one's going to be due next Monday. Back here, this one. Okay, so 3.2 we've got measures of dispersion. 3.1 was just measures of central tendency. Where's the middle of our data set? Measures of dispersion measures how spread out these things are. And so we've got, really, we're going to use standard deviation most of the time. We're going to talk about the range first, and then we'll talk about the standard deviation and the variance. The variance isn't used all that often. And then we'll talk about the empirical rule at the end. But we'll start off with the range. The range is really easy to find. Oh, I forgot this had this example in it. I don't like this example. Did I keep this in here? Yeah. Okay. Let's skip this one right now. This is just illustrating what it means to be spread out. For this one, we've got 30 customers for each restaurant. During the lunch hour, they took a random sample and they figured out how long each of them had to wait. They ask you what the mean wait time is, and then we do a histogram. Give you the answer. The mean wait time, I don't remember exactly what it is, but it's the same. The average wait time is the same for both of them. So on average, these people are staying kind of, oh, there it is, 1.39. No, calculated, so not that big a deal. The important thing is just that the mean is the same, but if you do a histogram, this one right here, they're a little more spread out. So you've got a lot of people who like barely had to wait at all, but then you've got some people over here who had to wait a really, really long time. So if you look at Wendy's, this one is less spread out. You've got these three really tall ones right here. So you've got most of the people who have to wait, you know, a moderate amount of time, a few people who barely had to wait, and then just a small number of people who had to wait more than that, but nobody more than 4 minutes. Whereas here you've got some people who did, you know, up to 5 minutes. So this one's a little bit more spread out on the number line. These are a little bit more close together. So even though their average is the same, their histograms look different because one is more spread out than the other. So what we're going to be doing in this section is measuring how spread out these things are, so you know if they're kind of clustered really close together or if they're really spread out on the number line. And the first thing we're going to do is the range, which is called capital R. This formula won't be given to you, and your TI-84 won't calculate it because it's pretty straightforward to do the range. Right. So what you're going to do is take the largest number that you see, subtract the smallest number that you see, and that's the range. Have that formula written down. Okay, so for this one, if you find the range of the data set that we did last time, back to the original 7 people, so the 130 guy didn't work out. I guess maybe he quit because the commute with the time was too long, maybe something like that. But if you have just these 7 people, if we find the range, the largest number we see is the 43. The smallest number we see is the 5. So if we just subtract those out to get 38, that's going to be our answer for the range. So the range is super easy, but it's also not all that helpful because it just uses the largest number and the smallest number. It doesn't tell us what's going on in between those two things. So it doesn't tell us if the other numbers are kind of like evenly spread out on the number line, or if like all of them are 23 just stacked on top of each other. So it really doesn't tell us what's going on in between. So what we're going to do instead is figure out the standard deviation and the variance. So first we're going to figure out the variance, and we'll talk about how to use this formula. We'll talk about it, we're not actually going to do it. So we're going to skip those examples where we calculate it by hand, because I mean honestly you guys aren't going to calculate it by hand. I wouldn't calculate it by hand. But I'll just go through and talk about the formula and how it's used, but then we'll skip the example. So if we talk about the variance, that's going to be better than the range because it uses all of the values within the data set, not just the largest and the smallest. So it gives you a better idea across the board what these numbers are looking like. Okay, so they use a lot of math jargon here. The sum of squared deviations about the population mean divided by the number of observations. Holy Lord. Okay, so whatever. We'll do the formula in just a second. Okay, so here we have the variance. It's going to be a lowercase sigma, not the capital one that looks like a big E, but the lowercase sigma with a little squared attached to it. And that's going to be your population variance. Again, we've got Greek letters because it's population. When we do the sample one, it's going to be our Roman letters that we're used to doing. Okay, so here's how we actually calculate it. What we're going to do is we're going to take mu, remember that's the average. So each of our data values, we're looking how far away is the data value from the mean. So subtract them to find that distance. Find that distance, square it, and then take the average of those distances squared. Okay? They have to square it because otherwise if you don't square those numbers and you divide by n, you just get back a 0, and that's not helpful. So that's why they have to square it in between. So they're finding for each value, how far away is it from the mean, square it, add them all up, divide by how many there are. That's how we get the variance. But like I said, we're not going to do that by hand because it's so much easier to do. But that's the formula for the variance if you have a population. And then it's sigma squared. If you have a sample, so here I think they do an example. We're not doing that example. If you want to fill them in, you can and do it by hand. We can just do it using our calculator. It's easier. So we're going to skip that for now. So for our sample variance, instead, now we're going to use an S, so a lowercase s for, well, it's for standard deviation, but we'll talk about that later. So it's a Roman letter because it is a sample. It's going to be the same formula. You're taking your numbers, finding the distance to the mean, square it, and then divide by, in this case, we've got n minus 1. So we don't have n anymore, we've got an n minus 1. So these formulas are going to be slightly different for populations and samples. You don't have to use the formulas, so knowing which formula to use is not a big deal. You're just going to have to know that there is a difference, and you'll have to know sigma is for population, S is for sample. So there's going to be 2 of them in your calculator, you have to know which one is which. Okay? So you don't have to know what the difference is, you just have to know that there is a difference. Okay, so other than that, formulas are very similar. N minus 1 is called the degrees of freedom. We're going to see that pop up again later. You don't have to memorize that, but we are going to see it later in chapter 9, I think, where when we deal with samples, we have this number, N minus 1, and we call it the degrees of freedom. Okay, so then they have an example, but we're not doing that. Okay, so the problem is, come back here. All right, so if we have something like inches, so if we're measuring something in inches and all of our data values are in inches, we find the distance here between